Hello, today I'm going to be teaching you all about logarithms that you would typically cover about high school. So let's start off with the very fundamentals. So if you get a question like 2 to the power of x equals 4, well, how would you solve it? Most of you would just do it through memorization, and that's the ideal method here because it's so simple. We know that 2 squared equals 4 and therefore x equals 2, right? Well, this is extremely simple. It's basic memorization, but you know how to do it because you know that 2 squared, which is 2 times 2, is 4, right? So that's really simple. But what about 3 to the power x equals 31? How would you solve that? Well, we know that 3 cubed, this right here, is equal to 27, which is just 3 times 3 times 3. And 3 to the power 4 is just 3 cubed times 3, which is just 81. Right. So how would we find 3 to the power x equals 31? We know that 31 lies between 27 and 81, which means that x must be between 3 and 4 right here. Okay, so that means we know that x is somewhere between this range. Now how would we find out the value of x? That's the tricky part. You can't do it through mental calculation, or at least do it very accurately, but here's the best way to go about it. And you're going to need a calculator, but if you write it in the simplest form, you'll get it accurate. So this right here is where you use logarithms. So when a to the power of x equals b, to find the exponent right here, which a is raised to the power of, you can use the function log, and log b to base a gives you the exponent a is raised to. And using that example, we see that a is equal to 3 and b equals to 31. If we were to write it down in this state, we would be getting x equals to log 31 to base 3, which is approximately 3.13 in 3 significant figures. And that's exactly how you solve a question regarding logarithms. And we pronounce this value right here as log 31 to the base 3. So this is the very fundamentals that you need to get right. It's just basically finding the exponent of a value to satisfy an equation. So moving on, we have the basic identities. A to the power of 1 equals a. I'm sure this is extremely familiar. In fact, this is just common sense. But now we have another property. So if we were to write it in logarithmic form, we had a to the power of x equals to b, and therefore x equals to log was equal to log a as the base and b as the final value. So if we were to write that in that state, we'd get this right here, and that's equal to 1. And this is just a fundamental property, because if we ever had a question like 5 to the power x equals to 5, we need to find the value of x. You don't need to do log 5 to base 5. Instead, you just know that x equals 1 because 5 to the power 1 equals 5. So this is more of a common sense property, but the property that comes next is extremely important. So right here we've written that x equals to log b to base a. It's the property that I've said before, and it's really easy. So if you were to write it in a normal function, you'd be getting a to the power x equals b, and we know that x equals to the log of b base a. And if we just substituted this value of x into the formula right here, we'd be getting this new formula, which is a to the power of log b to base a, which is equal to b. So this is an extremely important one, because if you mess this part up, you cannot do any of the properties that come next. Now there's this property right here, log 16 to the base 2. So that's basically 2 to the power of x equals to 16. So right off the bat, you can tell that it's just 2 to the power of 4, and therefore x equals 4, right? That's exactly how you do it. But if you were given algebraic based questions like log x cubed with base x, it will be 3. And why that's so? It's because when you have a number as a base and you have the same number as your final value but raised to a certain exponent, that exponent becomes your final answer. Okay, and therefore you have the introduction to the third basic identity. Log of a to the power x to the base a is always x. Important properties, just keep it in your mind and you will ace it. So moving on, we have the addition and multiplication properties. So this right here is the fundamental property of logarithms. You're going to be using this all throughout if you take math as a major. Now this right here is the fundamental property that we're going to use to prove this is correct. So let's start off with the very first step. Let's actually understand what it says. The logarithm of a to the base x plus the logarithm of b to base x equals to the logarithm of a times b to the base x. You may be wondering why it's not a plus b, and well, this proof is going to show you why. So the very first step, we can just decompose log ab to the base x as this right here. So blue is supposed to indicate a, and this right here is a, right? And it follows this property right here, because when your base is x and you do this right here, you're going to get a, and this is the fundamental property that I've said from before. So in this case, a to the power of log b to base a equals to b. So if we did x to the power of log a to base x, we're going to get a. So this is just basically a in another way of writing, and in the same way this is b right here. Okay, just refer to this property and you will understand what's going on. This right here is b, this is b, right? And we've just rewritten it now using the law of exponents. Okay, we can rewrite this. Okay, now we can rewrite this as x to the power of log a to base x plus log b to base x, because when we multiply two values with the same base but different exponents, we add up their exponents. So for example, a to the power of m multiplied by a to the power n equals to a to the power m plus n, and this is the fundamental property we're doing here. When we multiply two values with the same base, x and x, we're just adding up their exponents right here. Remember, we're multiplying them, okay? And that gives you this value right here. When you close the brackets, you get this right here. Now we use the property that we've learned before, and we can just cancel out the logs on both sides, okay? And we get this right here. This is your answer, and that's how you prove that log a to the base x plus log b to base x equals to log ab to base x. Really simple property, and these are just referring to the previous properties right here, okay, where we've mentioned about this property right here and this property right here. Everything else is just simple math. Now moving on, we have the subtraction and division. Here is a property. So log of a to base x minus log of b to base x equals to the log of a divided by b. How do we prove this one? Well, try pausing the video and try proving this using the knowledge you've done with multiplication and addition. Well, if you find it hard, well, here's the explanation. So once again, a is blue and b is in yellow. So we can rewrite a as x to the power log a base x, and we can rewrite b in that similar way. And similarly, when you do a to the power of m divided by a to the power n, this is the exponent rule, we get a to the power of m minus n. Okay, and that's exactly what we're doing here. We're doing x raised to some exponent divided by x raised to another exponent. So when we have two exponents, we subtract them. That's exactly what we're doing here. Now when you remove the brackets, you're going to be getting this. Okay, so we can right off the bat, we can use the logarithmic properties that we've used before, and we can just cancel out log x and this x here. Okay, because we know that log of a to the power of a to the power of this, so we know that the log of a to the power x to base a is always x. Similarly, we have a as our x here, and this is our exponent. This is our x value in the property that I've used earlier, and that's just what's written over here. And that's how we prove that log a to base x minus log b to base x equals to the log of a divided by b to base x. Now let's talk about the exponent law. What is it? Well, you can't really say what it is unless you've seen it. So here is how it's gonna go. This right here is the law you gotta know. So log of a to the power b to base x is just b times log a to base x. How does that even make sense? You're raising the power of a to base b and to exponent b, and now you multiply the logarithm. Well, let's prove that one as well. You can take your time to solve it by yourself by just pausing the video, or you can just bear with me and see the videos. So right here we have log a to power b to base x, and if you were to write a in a different form, this is exactly how you would write it as, right? Now here's the next property of exponents that we gotta use. So a to the power of m whole to the power of n. Okay, and that's exactly what we're doing. We've written a as x to the power of log a to base x, and then we have to hold this to the power of n, and that gives you a to the power of m multiplied by n. And that's what we're doing here. That's exactly what we're doing here. So we've taken the x and we are taking the exponent and we're multiplying with b to give you this exponent right here. And like I've said before, log of a to power of x with base a is always equal to x, and you can see here we have the same basis right here, and therefore your exponent is your final answer. And that's how you prove the exponent law. These names are not exactly given as exponent law, I just come up with it so that it can be easier to understand what I'm referring to. Now moving on, this is the property that you're gonna use. Okay, so this right here is a question to test your knowledge. You can pause the video, take your time and solve it if you want, or you can just see the video and see how I would solve it. Well, 7 to the power of 3x plus 1 equals to 5 to the power of 2x minus 3. How do we find the value for x that satisfies this equation? Well, firstly we can put a log on both sides. Now I'm sure that you may have had a doubt. How do you have a logarithm without a base, right? We just have a log value. Well, this is called a baseless logarithm. It has no base as such. This is mainly applied using equations, but normally we use logs with bases like log a to power b with base x. Sometimes you will not be granted that opportunity to use a base x or any base for that matter. So when we have equations, we don't use bases, but it does not change the properties. All the properties and identities that you've used before apply to the same logarithms here. And using this property right here, we can see that a is 7, b is 3x plus 1, and so we can rewrite that as 3x plus 1 times log 7. And similarly we've done that to the right hand side as well, and we get this right here. Now using the distributive property, or the FOIL method as some would like to say it, you can multiply 3x with log 7 and we can add that with 1 times log 7. Okay, and that will be equal to 2x times log 5 multiplied by negative 3 times log 5, and that's exactly what I've written right here. So 3x log 7 plus log 7 equals to 2x log 5 minus 3 log 5. Now I want to simplify negative 3 log 5. Using the identity right here, I can if I wanted to, I could simplify it. It's not essential, but it's easy to do so. We know that 3 log 5 can be written as log 5 to power 3, because that's just reverse engineering our property, and that gives you log of 5 to power 3. 5 to the power 3 is just 125, so we can write 3 log 5 as log 125, and that's exactly what we're doing right here. And yeah, that's what I just did. I just rewrote everything right here. Now let's move the like terms to one side. So we can move this 2x log 5 to this side with the 3x log 7, and we can move the log 7 to the constant here, negative 3 log 5. And doing so, we just swap the right hand side and left hand side, or we can subtract, whatever way you like to do it. We would get this equation right here. Now the next step is to factorize. So if you want to isolate x from two terms, the best way to do it is to factorize, especially when they have the same degree of the coefficient, right? So when you have x, we can factorize x and we get 3 log 7 minus 2 log 5. What is 3 log 7? Well, 3 log 7 is just log 7 cube, which is log 343. And what is 2 log 5? That's just log 5 squared, which is just log 25. Okay, and so if we rewrite this, we're going to be getting negative log 125 minus log 7 divided by log 343 minus log 25. This is your value for x. Now if you just multiply the numerator and denominator with negative 1, which doesn't change the value at all, you're going to be getting this, a more neater way of expressing it. But regardless, both of the values are equal and they will both equate to negative 2.59 if you round it to 3 significant figures. And you can plug this value into your calculator and you'll see that the values are almost equal because we don't have the exact value. But if you plugged in this value or this value right here into your calculator and perform this equation, you're going to see that they equate. Now moving on to another property. Well, let's start off with natural logarithms. I'm sure you've heard of regular logarithms, but have you heard of the natural ones? Here's a famous number, e. You know this as Euler's number. It's an irrational number and it is approximately 2.718. okay, it's approximate. This right here means approximate, and this is just used lots in mathematics. It's extremely useful, but we call these functions called as an exponential function. Okay, so whenever we have a function like y equals to f of x, and when f of x concerns the usage of e, we call it an exponential function. Okay, now not in all cases where e is present we call it an exponential, but in most cases like y equals to the e of x, this is an exponential function. Moving on, if y equals to e to power x, which is exactly what I've stated right here, ln y equals x. Now what is ln? That is your natural logarithm right here. So if we were to reverse e to power x and write it down into y, we'd get ln y equals x. You may have some doubts right now, but I'm going to clear it right now. So let's say that we had okay, here's a simple idea. So we have 15 equals to 5 times 3. Okay, now what ln does is basically undoes it. Let's say that e performs an operation of multiplying by 3. So if we divide by 3 on both sides, it still satisfies the equation right here, and that's what you do. You're undoing the operation. So if e multiplies a value by 3, ln does the opposite. It just divides the value by 3. And so they're just inverse functions, and that's exactly what they are. Okay, so y equals ln x and y equals e to power x are inverse functions, meaning that if you perform e and then you perform ln, you're going to get no change in the operation. And if you perform ln and then you perform e, you're still going to get no change in the operation because they are inverse. Now moving on, and by the way we can classify this as f of x is a regular function. When you multiply it with your inverse function, okay, sorry, that's not the way you write it, f inverse x, this is just equal to x. Okay, and that's basically it. That is what an inverse function does. It does not change the value at all. So if we did ln on both sides in y equals e to power x, we'd get ln y equals to the ln of e to power x. Now we are performing the operation of e onto x, and we are performing the operation ln onto x. Given that both ln and e are used just once, they're going to cancel each other out, and so ln e to power x is x. They're a normal function and an inverse function, so the value is unchanged, and ln y stays as it is. So we get x equals to ln y, and the same applies if you did e. So if you rose both sides to the power of e, it undoes the operation of ln. Okay, and that's what I was saying before. So if y equals to ln of x, if we raised both sides to the power of e, we get e to power y equals to e to the power of ln of x. Okay, and we know that y equals to ln of x, right? So raising e to both sides, we can see that in the right hand side an e operation is performed and an ln operation is performed. Therefore we can cut down both operations, and that's just the same as x. So performing an e and an ln, which is just a regular function times its inverse function, cancels out any change that's carried out on the value. Okay, so this is just an introduction to natural logarithms. You're going to be using this a lot, and differentiating it is not going to be covered this lesson, but will be covered in the future. So let's give a question regarding normal logarithms. This is not regarding natural logarithms, it's your simple log values. And I've seen these questions, these type of questions come up in the SAT. So I think it's quite important that you learn this. So we have a question right here, okay, and how would you solve this? Well, first step is to bring all the terms to the left. Second step, which I feel is the key point, after this it's all simple. You have to recognize that this is a quadratic. Okay, we can write 6 to the power of 2x as 6 to the power of x whole squared. Okay, it's the same thing because a to the power of m to the power n equals to a to the power mn, and if we just reverse engineered our a 6 to the power of 2x, we can get 6 to the power x whole squared. And that's the key feature. You have to learn this. This is the most important part when you're solving questions like these. Okay, after that it becomes smooth sailing for you. So if we did this right, we can see that your typical x in the quadratic equation is actually 6 to the power x. Now we can't say that x equals to 6 to the power x for substitution, so we're going to use another variable y. Okay, that's exactly what we're going to be doing here. So y squared, we're just replacing 6 to the power x with y all throughout. Okay, and therefore we get this equation right here, y squared minus 9y plus 8, and that's equal to 0, right? Now we know how to split the values. Okay, so we know the basics of factorization, I'm sure. So we have to make sure that when you split negative 9y, the two values that you split sum up to negative 9y, and when you multiply the two values regardless of the y coefficient, regardless of the y term, you should be getting positive 8. So what two values such that a plus b equals to negative 9 and a times b equals to positive 8. We can try out the multiples if you would want to, but I think that is a bit tedious because this is quite simple for you to understand right now. So in doing so, you'd get negative 1 and negative 8 because they both sum up to your value negative 9, and when you multiply negative 1 and negative 8, you get positive 8. And I'm sure you know this factorization trick, and this is crucial because this is what the entirety of this question relies upon. So when you factorize the first two terms, you can see that y bracket y minus 1, that's your common factor there, and y minus 1 is going to be the common factor here as well, and negative 8 is another factor. So we have y minus 8 times y minus 1. Really simple, right? Well, here's the thing. When you get y equals 8 or y equals 1 as your answer, you're not done yet because you're using a substitution. Remember, we're using substitution. So 6 to the power x equals 8, or y equals 2, or 6 to the power x equals to 1. And this is the tricky part because most people just leave out their answer like this, but that is not how you do it. So given that we've used a substitution, we have to write it back into its original form. 6 to the power x equals to 8, and 6 to the power x or 6 to the power x equals to 1. Now this is your simple logarithmic formula, which means that x equals to the log of b to base a, and doing that we get our two answers. So our first answer for 6 to the power x means that it's going to be log 8 to base 6, which is approximately 1.16, and your second answer, which is log of 1 to base 6, is 0, because when you raise anything, okay, when you raise any value a, for example, to the power of 0, it's always equal to 1. Okay, and that's important, and that's exactly what we've used here. So our two values over here would be x equals 0 and x is approximately equal to 1.16. And yeah, that's just the basics of logarithms. This video right here should be able to take you through the majority of high school math regarding logarithms, because you don't tend to get the university type questions at such a young standard, right? So this right here is exactly what you need to know about logarithms, and here's a summary of everything that I've used. So this is the two basic identities that you got to know. This is the natural logarithm, both of these, These are the laws. So this is the exponential law, the addition multiplication law, and the subtraction division law. I hope you enjoyed watching this video and actually took away some knowledge that you can use in your math. And I hope you've enjoyed, and I hope you subscribe and like, share. Thank you.